Hello and good afternoon, scholars. Welcome back to Mr. Sniffen's geometry class. Today we're going to be talking about the line equation and more importantly, the y-intercept in our line equation. You may remember from algebra class or from geometry class as well too. Our line equation is what we use to give directions for a line. We have these various components we've been talking about the last couple of days, like humans need time, lines themselves, they need a y-intercept. They need a place where they intercept on the graph to kind of give them positionality. And then from there, they have a slope or kind of the direction they're heading off or to what coordinate that line is going to continue on into infinity in. So let's take a look at our notes for today. Just as a normal, typical reminder, we have our title up on the top here. Today is, I believe, July 15th when you should be watching this, and this is going to be one of two pages we got going on. Pretty quick, pretty fast and simple for today. As a reminder, our line equation is going to be that formula of y equals mx plus b. So y equals m times x plus b is going to be our various portions that we need. Our y and our x are going to be pulled directly from our graph. Those are going to be little different points that exist on our line. We're going to take a point from our line, extract those values, the x and y, and pop it directly into our equation. The next component here we have is what we call the m value or m variable. That is always going to be our slope. If you have some questions about how to find slope, we're going to do an example here today. But if you watch our previous video, we go through everything you need to know about slope. But that's your direction essentially. Your up and down, your left and right, how numerically, how much you're going to be doing that. The last component we're going to be talking about today, our last variable, is going to be our y-intercept. And that's essentially the numeric value of where our line is going to be blasting through our y-intercept. So once you got this down in your notes, let's take a look at our next section. If we want to just define our y-intercept, we're saying it's our b value, which indicates where our line intercepts the y-axis. So we need all of these values. These four different variables are going to dictate everything that we need to know about a line. Every single thing that we need to know is going to be contained within that piece of information. As long as we have something like a y and an x value and a slope, we can go ahead and solve for our b value. If we have a b value and a y and an x, we can get our m, and so on and so forth. What we're going to be looking at today, for the most part, is the steps to solve for a b value. For instance, if we're given some pieces of information, say like a y and an x and a slope, we have the ability to solve for that missing component, that b value. There's two different things that we can do. On any type of graph, if we already see the actual line, if we're actually given a graph with a line on it, the first thing that we can do, or the easiest thing that we can do, is just visually identify that variable. Just like yesterday, how we had our slope and we can basically just use our fingers and count up and down our line and kind of plot everything out. If we know a values here, say like if we know this is intercepting at 2 on our graph, we know that we can just go into our equation and pop that b value in as the number 2. That would be the easiest thing, but if we don't have that, if we don't have this piece of known information, say like we're just given some points associated with our line, like we're told just the x, two versions of the x and the y, two different spots that are here, we're going to have to do is go ahead and fill in all of our known values. So pretty straightforward. You either can see it, and if you can't, you're going to have to go ahead and do a few steps to solve for that missing piece. Once you got that written down, let's take a look at our next page, our last page. We're just going to have an example here of what we actually do to go ahead and get our b value. So up on your screen, you should see an example of, or a picture of, a graph. In this graph here, we have a few different points that are going to be listed out. And what I would like to do is work with the x and y point, or what you can see is that bluish circle at 0.31. And we're going to go ahead and insert those, that 3 and that 1, into our original equation. So our first step here is we're just going to go ahead and insert our known values, which we called 3, 1. Or if we're going to start to fill in our equation, we're going to look at it as 1 is equal to our unknown slope times our x value of 3 plus our unknown of b. So cool. There we go. That's our first portion. Our second step here is we're going to solve for our unknown values. Given the information so far, we don't have our slope yet. We don't have an m value, but we do have different points that exist on this line that we can see that we'll be able to kind of use and generate our own slope. To generate our own slope, we can go ahead and just count out normally like we did yesterday, or we can use that slope equation. What I'm going to do for our slope equation is I'm going to use points 3, 1, and the point next to it of 6, 5. I'm going to say my x1, my y1, my x2, and my y2, and I'm going to use that slope formula. y2 minus y1 over our direction left and right of x2 minus x1, and we're just going to find the difference between these 2 points. We punch in our values, and we're going to end up with 4 over 3. So this is how we get our slope. As always, we want to make sure we box in our answers just so we can go back and kind of, see it quickly. Our next portion here is we're going to just to kind of show you a little process here, we're going to insert our m value now into that equation. What that's going to look like is we're just going to slide everything in. We have 1 is equal to our m of 4 over 3 times 3 plus b. And our b we don't know right now. So if we do not want to use a calculator, and here we're practicing math, we want to learn the other skills, not rely upon a tool, but be the tool ourselves. Multiplying fractions like this one here, 4 over 3 would be the same thing as doing, say, 3 over 1 and just multiplying across. So we're looking at 12 over 3. 12 over 3 is equal to 4. So we're going to say 1 is equal to 4 plus b. If we're looking just in our head right away, we're going to know we're going to have to minus 4, and we end up getting a negative 3 here as our b value. One thing to consider, and we've seen this in circle equations as well too, is that when we have this negative value for b, it's going to end up changing our formula. If we do plus negative 3, we can write that out, or we can just do minus 3 in our equation. So let's take a look at what that's going to be like. So we know our final step here, write our final equation, leave y and x as letters. What we're talking about is taking that y equals mx plus b, inserting the unique values. Unique values, what we call like our direction points. Because there's an infinite number of y's and x's on this line, but it has specific directions it's going to go. It's going to go up 4 and to the right 3 every time, and it's only going to intercept at the y. So we can write our equation as this, just y equals 4 over 3 times x minus 3, or if you want, you can also do it like this. You can say plus negative 3 in parentheses, but normally you're going to see it written in this fashion. So that's your video for today. Once again, we're trying to go through, do some speedy ones here, trying to get you into that 10-minute time frame. Your task for today, your practice for today is going to be up on Delta Math, which is exactly where I got this particular question from. You got a couple different ways that you're practicing your Y-intercept. One is going to be this graphical version, where you're then going to go ahead and insert that answer of y is equal to 4 over 3 times x minus 3. If you're wondering how do I write the fraction portion out, in Delta Math there isn't a fraction button. What you basically just do is y is equal to parentheses 4 divided by 3, close your parentheses. That's oftentimes how people write a fraction on a keyboard if they're not using what you would call like Unicode or latex coding and other computer stuff. But yeah, so that's it for today. As always, if you have any questions, things like that, please feel free to contact me. Email me, text me, or come to office hours, and we can go through various practice methodologies of this. Just so you're aware, on Friday, you're going to have a short little quiz going over some of the stuff from this week, which is basically going to be our line equation, the components of it, and what you'll see tomorrow would be our distance formula, and from yesterday, your midpoint formula. So on Friday, practicing those 3 concepts, a little bit of that history from Monday as well too. If you have any questions, please stop by. Thank you for your time. Appreciate it, and have a nice day. Bye.